Hello, my name is Aitor Fernández and I am a researcher member of the Hydraulic R&D group of the University of Oviedo, and I am going to present our project called Obtaining Energy in a Water Distribution System using a small vertical axis hydrokinetic turbine as a practical example. We're experts in electronics and mechanics from the University of Oviedo and Port Said in Egypt have also participated. It is estimated that the world's population will grow up to 11,000 million by 2075, which translates into a considerable increase in energy demands. This growth is uneven according to the degree of development of the countries, being much more pronounced in the case of the underdeveloped countries. It should be noted that underdeveloped countries do not have a developed complex electrical network, so many of their demands cannot be covered. This means that there are many isolated points where electricity is not available. To solve this problem, new green energy technologies must be developed. Nowadays, renewable energy represents the 21% of all energy generated in the world, but it is estimated that in the coming decades, its weight will increase markedly. For example, the International Energy Agency has estimated that in 2050, more than the 40% of the world's energy will come from hydrocarbon resources. Focusing in the renewable sector, hydraulic energy is the most important green energy, representing more than the 20% of all the renewable sector. But the use of dams is not expected to grow, mainly because of environmental and economical issues. New green energies will grow significantly, although this will require a strong technological development. To reach these targets, the use of water distribution networks as a renewable resource can be a suitable reality in the coming years. These facilities can supply energy to isolated points, combine water supply with energy generation. Due to the use of new turbines designs that have compact sizes, both the size of the facility and its easy start-up process will reduce environmental and investment impacts. Until now, the research lines carried out can be divided into two large groups, according to the installed power, low power and high power. On the one hand, low power facilities are mainly based on the use of pumps as turbines and axial turbines like windmills. So water losses can be harnessed. On the other hand, high power facilities use traditional turbines like Pelton, Kaplan and Francis designs, but installing these devices in water distribution networks. Our proposal goes a step further. Using a vertical hydrokinetic water turbine, the generation of energy from a water stream current can be made easily and cheap. The main element is a vertical rotor that is connected to a permanent magnet generator where energy is generated. Then, different sensors are fed with the turbine's energy without requiring a connection to power main, working on a standalone way. The management is made by using Internet of Energy methodology. In this case, the energy is stored on a set of batteries whose energy is going to be used in a standalone way to feed a series of sensors and actuators by a coator company. These sensors are divided into two different groups. Control devices to manage the power stage of the turbine and to open and close the water gates, and measurement devices that recollect data from the water quantity and quality of the channel. In this way, the company can monitor and send orders to the facility remotely. This represents significant cost savings and improved the service efficiency. As it can be seen, on the one hand, the mechanical setup is formed by a vertical axis water turbine that is connected to a generator, being everything on a metallic structure that is coupled to the channel ways. On the other hand, as it has been said, Internet of Energy methodology have been used to send and receive all usual information. For this, an electronic sensor module has been developed, formed by a node MCU where all wireless connections are housed, and hardware where the power and device connection are housed. The Internet of Energy methodology is a novel development where information collected by the different sensors is sent wirelessly to a server called broker. Then, the different clients subscribe to that broker and receive the information they require. You also have the possibility to submit orders to perform some action at the location, for example, to close the water gate. All this methodology has been tested under laboratory conditions, using a water current flume where the turbine, sensors, and devices are also installed. Here you have one picture of this device. As it can be seen in the video, the experimental procedure starts with the turbine rotating into the current water flume. First, the developed system has been tested sending orders to the actuator by using a smartphone app. In this case, we want to switch on the LED as a controller, and then we want to receive information about the power generated by the turbine and its rotational speed. You can see here that we want to obtain that information, and as a controller we made the easiest way, that is to turn on a light. The same procedure has been made with a computer. First, it has been tested actuation action by switch on the LED, and then we have downloaded a database with the turbine's power and rotational speed. This information is useful to obtain the power curves so the rotor's behavior can be studied. After the laboratory testing procedure, a real emplacement has been selected to test under real conditions the whole system. This location is situated on a mountainous region to test in extreme situations, and it is part of the water distribution network of a city of 270,000 of inhabitants. This prototype will be useful to observe what things we should improve and see some errors that the device may have. Until now, we only have installed the turbine and its structure, but any test has been made. Finally, some conclusions can be obtained from this proposal. First, water distribution networks are suitable to produce energy and to supply isolated demands. Secondly, this can be possible due to the use of new vertical turbines that can be useful even with low water speeds. Thirdly, the use of Internet of Energy methodology is a novel technique that has a promising future, being in this case tested under laboratory conditions with good results. Finally, a real emplacement has been selected to test this proposal under real conditions. That's all. Thank you for your attention, and I will gladly answer your question.